Solution concentration. There are many ways to express the amount of solute dissolved in a solvent. Below are the concentration expressions that will be used in this course. Molarity, symbolized by capital M, percent by mass, and mole fraction, symbolized by capital X. In all cases, the more solute in a given amount of solution, the higher the concentration. Concentrated solutions have high concentrations, and dilute solutions have low concentrations. Molarity, as represented by capital M. Two solutions can contain the same types of solute and solvent, but be quite different due to a difference in the proportion of the amounts of each. Molarity is one way to measure the concentration of a solution. Molarity, capital M, is equal to the moles of the solute divided by the volume of the solution in liters. Mass percentage of a solute. Mass percent is commonly used on consumer product labels such as bleach. If the label indicates that the active ingredient in bleach is 7.4% sodium hypochlorite, that means that in 100 grams of bleach there are 7.4 grams of sodium hypochlorite. To find the mass percent of some given solute A, which in our example would be the sodium hypochlorite, you take the mass of A in the solution and divide by the total mass. In order to find percents, we're taking the part, so just the part we're interested in, A, mass of A, and divide it by the whole, the total mass of the solution, and then multiply by 100 to express your answer as a percent. Mole fraction, or X, is commonly used to describe mixtures of gases. This expression assumes a solute A is dissolved in a solvent B. So if I want to find the mole fraction of A, I take the moles of A and divide by the total moles, or A plus B. Example 1, molarity. A solution contains 10 grams of silver nitrate in a 300 milliliter solution. What is the molarity of this solution? So the answer is walked through step by step on the next slide. So on this slide, I'll just focus on setting up the problem, and then we'll walk through each step on the next slide. So to find the molarity, we need the moles of AgNO3 divided by the liters of the solution. Okay, so let's first focus on moles of AgNO3. We're given 10 grams, and we need to convert that into moles. So the molar mass is about 170 grams per mole. Okay, and that is 0.0589 moles of silver nitrate. And then the liters of solution, if we have 300 milliliters, there are 1,000 milliliters per liter. That'll give us 0.3 liters. So we're going to take these two values into the next slide to get our final answer. So you can see here are our two answers from the previous slide, the moles of silver nitrate and the liters of the solution. Now we substitute that into the molarity expression and solve. So we have moles of silver nitrate here divided by the liters of the solution, and we get a solution that is 0.196 molar AgNO3. An experiment calls for 250 milliliters of 0.5 molar NaOH. How many moles of NaOH are being used in this experiment? So the first thing we have to remember is, what does this 0.5 molar NaOH mean? It means we have 0.5 moles of NaOH per liter of the solution. Okay, so in 1 liter of the solution, we would have 0.5 moles of NaOH. And the question is asking us, how many moles are there if we have only 250 milliliters of the solution? So 250 milliliters is 0.25 liters. Okay. So once we have this interpretation of molarity and our number of liters, we can find the number of moles of NaOH. Let's look at that answer on the next slide. So from the previous slide, we knew our volume, and we know that we have 0.5 molar or moles per liter multiplied by liters. So 0.5 times 0.25 is 0.13 moles of NaOH. Example 3, mass percentage. A solution contains 15 grams of sodium chloride in 750 grams of water. What is the mass percent of sodium chloride in the solution? So the percent by mass of sodium chloride is equal to the mass of sodium chloride divided by the mass of sodium chloride plus the mass of the water, so the total mass. Okay. So if we substitute here, we get 15 grams of sodium chloride divided by 15 plus, this is 15 grams plus 750 grams. Okay. So if we take 15 grams over our total, 765 grams, multiply by 100 to get a percent, and we get 2.0%, or about 2% sodium chloride by mass. Example 4, mole fraction. A weather balloon contains 28.5 grams of hydrogen gas and 1.5 grams of helium gas. What is the mole fraction of helium in the weather balloon? So mole fraction is the moles of helium divided by the total moles. So moles of hydrogen plus moles of helium. So we first need to find the moles of hydrogen and helium since we're given grams. You can just use molar mass to do that. Keeping in mind this is H2. So the molar mass of H2 is about 2 grams per mole. And the molar mass of helium is about 4 grams per mole. Once we know the moles, we can substitute into this equation and solve for X. Let's take a look at that on the next slide. So once we find the moles of hydrogen, using those conversions I showed on the previous slide, we get 14.1 moles of hydrogen and 0.375 moles of helium. We're looking for the mole fraction of helium, so the moles of helium goes on top, 0.375, divided by the total number of moles, so 14.1 plus 0.375 to get our total number of moles. Once we divide these, we get a mole fraction of helium equal to 0.026.